Imagine you are falling toward nothing. No planet, no surface, no color, just a circle of darkness hanging in space. A hole where the stars should be. Around it, a glowing ring of light burns like a halo, white, gold, and blood red, swirling in slow motion, as if time itself is moving through syrup. That light isn't peaceful. It's matter being shredded. Gas, dust, entire stars, all torn apart, stretched into filaments, then forced to spiral down into an invisible throat. You are drifting closer. At first, it feels distant, safe, like watching a storm on the horizon. You can still see the universe behind you, stars scattered across velvet black, the faint blue glow of your home galaxy. Quiet, untouched, but the circle in front of you, perfectly black. Perfectly round, doesn't flicker, doesn't sparkle, doesn't respond to anything. It just sits there, eating everything that comes too close, and then it hits you. There is no too close. There is only outside or gone. From far away, a black hole doesn't look dangerous. It looks beautiful. The glowing ring around it, the accretion disk, spins with hypnotic grace. Hot gas ripped from doomed stars forms bright arcs of light that smear as they whip around at unbelievable speeds. For a moment, it looks like a cosmic jewel, a perfect luminous circle hanging in the void. Even the darkness at the center seems artistic, framed by that halo of destruction. This is the kind of thing we put in posters, desktop wallpapers, movie intros. But something is wrong, because that hole isn't emptiness, it's an edge. The last edge, the final place in the universe where outside stops existing. You're moving toward it. Maybe you came here in a ship. Maybe you're in some future probe, sent to get close, to see what happens. Maybe this is an accident, a trajectory miscalculated by a fraction of a degree. It doesn't matter. You are now close enough that the hole has stopped being an image. It has become a pull. At first, you don't feel it. Space isn't like air or water. There's no wind, no sensation of moving faster. No roar announcing your fall. Gravity doesn't need sound. It just starts stealing options from you. Your engines work a little harder. Your course corrections get a little more sluggish. You try to adjust your path, and the black circle doesn't stay where it was. It creeps across the window, slowly, stubbornly, like a stain you can't wipe away. You are not plunging yet. You are being persuaded. But here's the problem. Black holes don't negotiate. They don't bargain. They don't give you a warning line on the floor and a sign that says, "Don't cross." They let you choose, right up until the moment your choice no longer matters. The scale hits you next. This isn't a little collapsed star. This is a monster, a supermassive black hole at the heart of a galaxy millions, maybe billions of times more massive than your Sunday. It looks small because it's so far away. But nearby, entire star systems orbit it like dust spiraling around a drain. We've seen hints of them, stars whipping around invisible centers, their paths bent in tight, frantic loops. Observatories watched them and realized something terrifying. There had to be something huge there that we couldn't see. We named it. We drew diagrams. We pretended that gave us control. You are now close enough that those diagrams don't matter. Gravity here isn't gentle. It isn't kind. It's absolute. And this is where things change, because in normal space, you can always try to escape. Fire engines, turn around, burn fuel. Here, every second you delay makes that escape more expensive. Miss your window, and the price becomes infinite. You still have options. For now, your ship can fire its engines, curve away. Try to slingshot around the black hole and climb back out towards safer orbits. Pilots and mission planners design trajectories like this around planets. All the time, gravity assists, slingshots, gravitational cheats to steal speed. But here's the problem. Black holes don't give speed for free. They take. When you loop around Earth, you can leave again. When you skim around Jupiter, you get flung out into deeper space. Here, the closer you get, the more the rules change. At a certain distance, there is a boundary. It isn't a wall, or a shimmer, or a glowing ring. It's an invisible point in space where outward stops existing. We call it the event horizon. You don't feel it. There's no bump, no shockwave. Just a quiet, mathematical murder. You are still outside it. For now, you can still turn on your engines and push away. The burn would be violent, long, and expensive. You'd feel every molecule of propellant gouging out its last contribution to your survival. But your ship responds. You change your orientation. Your thrusters fire. The black circle shrinks in your window. You get the illusion of control back. And this is where things change. Because the deeper you drop into this gravity, well, the more of your energy is spent just trying not to sink faster. You can't feel the gradient with your skin, but your ship can. The side closer to the black hole is pulled harder than the side facing away. Your structure flexes. The navigational software starts spitting out numbers that feel less like velocities and more like confessions. You are not in charge here. You are borrowing time. Light behaves strangely near the black hole. You notice it at the edges of the view. The background stars don't look right. They smear, bend. Some seem to duplicate, appearing in rings or arcs around the dark center. Space itself is warping. You are watching the universe being bent like glass heated too long in a furnace. The black hole isn't just a heavy object. It's a wound in space-time that curves everything around it, even light. You could fire a laser directly away from the hole and watch it curve back inward. You could send a signal and never see it arrive. But here's the problem. You are made of light, in a sense. The information that will one day describe you, your position, your motion, the particles that make up your body, will hit a point where its path doesn't bend. It ends. You drift closer. The accretion disk grows brighter, more detailed. You can see clumps of hotter gas, bright knots where matter is rubbing against itself at incredible speeds, heating up to millions of degrees. Get too close to that, and you won't even reach the black hole. You'll be cooked first. Your ship's hull would glow, then melt, then vaporize, your atoms stripped apart and added to the swirling river of doomed material. This is the environmental horror, not storms of gas, not pressure, but a circular river of fire that never cools, that never empties, that is constantly fed by things that get too close. But it gets worse. Because even if you somehow avoid that glowing disk, even if you fall along a path where the disk is thin, or you approach from above or below, you will meet something else. Gravity's cruelty at close range. We call it spaghettification. It sounds ridiculous, cartoonish, but there's nothing funny about having your body stretched like a rope. The gravity near a black hole isn't just strong. It changes over very short distances. Your feet, closer to the hole, feel a stronger pull than your head. Your spine is caught in a cosmic tug of war. At first, it's a sensation, a strange heaviness, a feeling like your body is being pulled apart very gently, like someone is trying to stretch you a few millimeters longer. Humans can survive small differences like that. You've stood in elevators. You've ridden roller coasters. Your body knows what mild force feels like. Here, the difference grows. Your bones become a chain under tension. Your organs slide in directions they were never meant to slide. Blood stacks up, nerves scream, and then things cross a line. The tidal force becomes so extreme that it doesn't just pull you, it rips you. But here's the problem. That is still not the point of no return. That's just pain. Imagine, for a moment, that you had the perfect ship. Infinite fuel, infinite thrust, armor that could withstand the heat of a star being torn apart, shielding that ignored radiation. Somehow, by miracle or madness, you handle all of it. Spaghettification, accretion disk, particle storms. There is still a line you will never cross backwards. The event horizon. Once any part of you slips past it, even a finger, even one atom, it no longer exists. In the same way, not in this universe, there is no trajectory that leads back out. No angle, no speed, no hack. You can point your engines directly away. You can burn hotter than any rocket ever built. You will not move farther from the center. You will only fall. And this is where things change, because every danger you've ever known, storms, explosions, radiation, still let you imagine escape. This one does not. Inside, time starts to break. Not literally, but in your perception. Your sense of before and after warps because the normal anchors are gone. No Sunday crossing the sky, no ground rushing up to meet you, no horizon, just a deepening pull that feels less like movement and more like being carried. You try to look back toward the universe, toward the place you came from, but even that feels wrong. Light from behind you curves, bends, wraps around the blackness. The stars seem to smear into arcs. You get flashes, memories, not just yours. Images you've seen of black holes from telescopes, from simulations, like the Event Horizon Telescope's first real shadow of one. A glowing ring framing an absence that isn't really empty. You remember thinking it was beautiful. Now, it feels like looking at your own autopsy photo in advance. But here's the problem. This isn't just about you. Everything that falls in is trapped by the same rules. Stars, planets, light, information. None of them ever come back out. And now, that includes you. The environment around you stops feeling like space. Space is wide, open. You float. Here, floating is an illusion. You are moving along a one-way tunnel, even if you can't see its walls. You can't stop. You can't turn around. The only thing that changes is how fast you're being dragged toward the center. The singularity isn't a place you drift to. It's a destination that owns your future. You might not feel the acceleration anymore because everything, your ship, your body, your atoms, is being pulled together at the same rate. There are no more relative differences to blame. No turbulence, no bumps, just a smooth, unstoppable fall. And this is where things change, because all the other dangers, heat, pressure, radiation, feel physical. This one feels existential, the loss of might, the loss of if. The universe shrinks down to one word, will. You will hit the singularity. You will be crushed. You will be erased. You try to imagine what that means. Crushed into what? Destroyed how? On a star, crushed means pressure and heat so intense that atoms are forced together, fusing into heavier elements. On a neutron star, it means the space inside atoms is squeezed out. Electrons and protons shoved into each other until matter is mostly neutrons. Black holes go further. We say the singularity has infinite density. That isn't a place you stand next to. It's a confession from our math. A way of saying, at some point, this stops making sense. You don't splatter. You don't break into pieces. It's worse. The very concept of pieces stops working. Your size, your shape, your state, all of it shrinks into a point that has no volume, only influence. You become part of the gravitational field, a contribution to the whole's mass, a term in an equation, nothing more. But here's the problem. Your story doesn't end there. Not exactly. Because your past everything you were is now written in a place no one can ever read. Information. That's the hidden horror. You're used to thinking of death as an ending. The body stops. The brain shuts down. Memories fade in the people who knew you. But the universe is stricter than that. On the deepest level, physics wants everything to be trackable. Every change, every interaction, every collision has bookkeeping. Attached information can be scrambled. Mixed, buried, but not destroyed. Except here, black holes take information in and never give it back. This is where things change. Because now we're not just talking about your body. We're talking about you. Every memory, every thought, every moment. Not just erased, locked away in a part of spacetime that no longer communicates with anything else. Scientists argue about what happens to that information. Some think the event horizon itself stores it in a scrambled form, a hologram, a skin of microscopic details encoding everything that ever fell in. Others imagine radiation leaking out over eons, hawking radiation, slowly letting the black hole evaporate, bit by bit, but they don't agree. They don't know. We are standing at the edge of what our laws can describe, throwing equations at a darkness that refuses to answer back. Black holes are the universe's way of telling us, number, you won't outrun this. You won't outsmart it. You won't build a better engine, or a clever loophole, or a last-minute save. There are places in this universe where the idea of escape doesn't exist. Not as a challenge, not as a dream, not as a word, just as a mistake. In the end, as the singularity approaches and your mind flickers, the universe does not apologize, it does not explain. It simply continues. Galaxies spin, stars are born, worlds live and die, black holes feast, and somewhere on a fragile dot of blue orbiting an average star, a species stares into the night and whispers, "We can go anywhere." But out here, in the deep dark where gravity has carved an exitless well into space-time itself, you finally understand the universe was never meant for us. We were meant for one sky, one gravity, one narrow band of safety. Everything beyond that is a promise we cannot keep, and black holes. They are where that debt comes due.